This video introduced the configuration of D1 screen serving as slave in modbus communication. There are 5 parts: wiring, download file overview, configure 22 file, project download, communication test. The first part is wiring. In the video, a 4852-232 adapter and a 232 USB adapter are used. Connect 485R plus to the screen phonics terminal block A plus R minus to B minus. In addition, the screen requires a 12-volt power supply. The second part is an introduction to the files that will be used in this tutorial. This includes the download files and the modbus setting guide for T5L and the instruction file. Download the file contains the UI interface, 13 and 14 files, 22 config file that needs to be rewritten to enable modbus slave mode, ICL files, D1OS file, necessary for modbus slave protocol. The 22 file is already configured here, so you can copy the file and just modify the corresponding address without configuring the initial 22 file. The D1OS file can be opened with the D1OS builder and can be used directly in common applications without extra modification. The modbus setting guide describes the corresponding instructions for the master and the slave and OS file. For understanding the meaning of the 22 file 16-byte configuration and the meaning of the 16-byte instruction parameter configuration. The instruction file is used for test. The third part is the configuration of the 22 file. Open the 22 file by the binary software Ultra Edit and jump to OX1C000 to start configuring the 22 file in bytes. Next, I will introduce the corresponding meaning of OXE000 to OXE007 mode. Open the modbus setting guide. I will explain the following configuration one by one. 5885 is to activate the modbus communication and set the screen as slave or master. Here 0001 means slave mode. Set baud rate 0480 for 115,200. Set the serial mode. 4 O's means no checksum. 8 and 1 mode. The address of the slave. The rest part keeps the default value. Next is the configuration of modbus instructions. This part is only required in the master mode. While the main purpose of the screen as a slave is to receive instructions sent by the master and display them, the instructions of this part can be referred to the video of screen serving as a master. Now the 22 file is configured. Note that you should not modify the 22 file on the D1 set folder because it will be overwritten when you save and generate in the project. You can copy the 22 file to the desktop and finally move it to the download file. The fourth part is project download. First of all, the project interface is configured. Here the data variable display control is used, and the VP needs to be set to be consecutive value to facilitate the instruction test of sending data to consecutive addresses. The more commonly used variables for modbus are data variable display, text display, and variable icon display. Click the control, draw the size on the background image, and set the corresponding VP and parameters. Note that the value of VP should be set to 1000 and above. I have made a project here, and you can refer to my configuration. After the project is completed, click Save and Generate. The controls and parameters will be generated to the configuration files. Download the configuration files to the screen to achieve a variety of display and functions. The download steps are as follows: copy the configuration files plus D1OS file plus configure 22 files to the SD card D1 set folder for burning. In the fifth part, we will perform a communication test by instructions written according to the descriptions in settings guide of modbus slave interface. All 3 instructions is to read the variable space. All 6 instructions is to write data to single variable space. 10 instructions is to write data to consecutive variable space. I have written the test instructions here, which is available for your reference. Open the project and remember this consecutive VP. I have written the instructions to SSCOM here beforehand. All 6 instructions is to write data to VP 2000. 5A is the slave ID. OX0064 is equal to 100. 8ECA is the check value used to check the preceding 4 numbers. You can set the fixed decimal in the project. If set to 1, the instruction 100 will be displayed on the screen as 10.0. Next, I will demonstrate the instructions one by one. Here, the baud rate is set to 115,200 and the hex send is checked. This instruction is to write 99 to VP, so 9.9 is displayed in the screen. Following this pattern, I marked the description of each instructions for your understand. This instruction writes 32 to VP 201, and this instruction writes 198 and 99 to VP 201 and 202. This one writes 97 and 98 to 202 and 201. The next instruction reads 33 and responds in hex to the master. The last instruction reads the value of VP 2000, 201, 202 and responds to the master in hex. You can see the corresponding value in screen and the computer. This test is a one-to-one test because modbus belongs to the half-duplex communication. If you want to do a one-to-multiple test, you may need to send a command several times to succeed. In this case, you can use DMOS Builder to open the DMOS file and comment out 681 to 694 before testing. Thank you for watching.